Have you ever wondered how your emails, streaming videos, or video calls magically find their way across the vast global network, hopping from one corner of the world to another with precision? At the heart of this intricate journey, defining a routing table's outgoing interface is its critical instruction on which physical or logical connection, a data packet, must leave the router to reach its next destination. When a router receives a data packet, its primary job is to determine the best path for that packet to continue its journey. It does this by consulting its routing table. The table contains entries that map network destinations to specific instructions. Each entry includes a destination network, the next hop IP address, and, crucially, the outgoing interface. The router first performs a process called longest prefix match, finding the most specific route entry for the packet's destination IP address. Once the best route is identified, the routing table entry will specify the next hop router's IP address, which the current router uses to forward the packet. To actually send the packet, the router must also know which of its own network interfaces is directly connected to that next hop. This is where the outgoing interface comes into play. It acts as the physical or logical port on the router that is associated with the path to the next hop. Additionally, if multiple paths exist to the same destination, the router uses administrative distance and metric values to decide which route is preferred. Administrative distance indicates the trustworthiness of the route source, while the metric quantifies the cost of using that route. Once the winning route is chosen, its associated outgoing interface is the one designated for the packet. For network engineers, understanding the outgoing interface is fundamental for configuring static routes, troubleshooting connectivity issues, and optimizing network performance. When you configure a static route, you explicitly tell the router which outgoing interface to use for a particular destination network. Without this specific instruction, or if the next hop is unreachable via the specified interface, the packet would be dropped or sent to an incorrect path, leading to network outages or inefficient data flow. This concept is deeply tied to what is known as next hop resolution. When the routing table specifies a next hop IP address, the router must then perform a recursive lookup. It looks up the next hop IP address itself in the routing table to determine which local outgoing interface can reach that next hop. This ensures that even if the next hop is not directly connected, the router can still find its way there. It is a vital step in ensuring proper data forwarding across complex networks. Ultimately, the outgoing interface is more than just a port number. It is the concrete instruction that translates a logical routing decision into a physical action, ensuring every data packet takes the correct first step on its complex journey across the internet, enabling seamless communication and efficient resource utilization.
If you love understanding how the web works, like, subscribe, and stay connected with us.